I hope my screen is visible. Good afternoon, everybody. Good evening, everyone. I'm Anina C.K. Biju, and I'm working here as a BIM application engineer grade 1. So today's section is about CAD standards. Let's talk about BIMLABS now. BIMLABS is situated in Kerala, southern state of India. We're also learning partner of Autodesk and member of Indian Green Building Council. The services provided by BIMLABS are BIM training for students and corporates, BIM implementation supports for corporates and organization, BIM project outsource, and BIM placement service. For more details, you can connect to the social media contacts of BIMLABS. So these are the certificates pursued by BIMLABS. BIMLABS have a membership certificate in Indian Green Building Council. So these are some other certificates. So the main office is situated at Karakotam, and we have branches at Statue, Cochin, Calicut, Dubai, project management at Dubai, and our BIM studio is in Techno City, Trivandrum. So the services provided by BIMLABS, these are the services provided by BIMLABS. The first stage is the finishing school. Here we provide soft skill training and technology training with project internship. And we have a project section that is BIM Studio, and then the Brit section where we provide placements service. I already mentioned before, BIMLABS Engineering Service Private Limited is an Autodesk learning partner, IGBC registered institute, capacity building partner of various AEC firms in South India. So BIMLABS is an authorized training center for Autodesk, Bentley, an authorized academic partner for Autodesk, member of Indian BIM Association and IGBC. So now let's come to our main topic, CAD standards. So CAD means computer aided designing. CAD is a use of computer to aid in the creation, modification, or optimization of design. CAD standard is used to increase the productivity of the designers, improve the quality of design, improve the communication through documentation, and to create database for manufacturing. So CAD output is often in the form of electronic file for printing machines or other manufacturing operations. The term computer-aided drafting, that is CAD, and computer-aided design and drafting, CADD, are also used. So CAD standards. CAD standards are a set of guidelines for the way computer-aided drafting, or CADD, drawing should appear to improve the productivity and interchange of CAD documents between different office and CAD program, especially in architecture and engineering. So these are some of the examples of CAD standards. First, we have the AutoCAD, 3ds Max, and Maya. And they are the commercial CAD software published by Autodesk. Blender, it is an open source CAD animation and image processing application with active community of users. Next is SketchUp, a CAD application that runs in a web browser developed by Google. So next is a standard of production which have some parameter. It includes layers and colors, scale factors, line types and line weight, font type and size, room and door numbering, title block and sheet titles, drawing sequence and sheet number, model paper space and external reference file. So let's go deep into this parameter. The first is layering and color. A layer in CAD is a way to differentiate between different lines that are drawn on a page. The layer can be assigned properties such as line weight, line type, and colors, and can be made visible or hidden, among the other things. Layer in a drawing for each different object type or construction elements. It differentiates the drawing by their colors. So coming to the next slide, the layer name format. We have a format to input layers into AutoCAD. So it is divided into fields. The layer name can be broken down into field. These field classifies the layer. At first, the field 1 is role, field 2 is classification, field 3 is presentation, field 4 is description. So, and the field 5 is view, and which is optional. So these are the descriptions of each field. The first field is role. A single or a double character denote the discipline. Example, if it is says A, then it means architect. If it is B, then it is building surveyor. So the field 2 is classification. It is a field for identification of content in the layer, usually displayed as a letter or letter with number. Example, if it is gives as EF, then it means elements or functions. If it is SES, then it is systems. Coming to the field 3, that is presentation, a code denotes a type of element. If it is D, then it is dimension. If it is T, then it is text. Coming to the description, the field 4 is description. It this allows the user to identify the content of the layer without solely relying on the details of the field 2, that is the classification. And the next is the last field, that is view. This is to denote how the layer is viewed. That is, if the drawing is elevation or section, so which layer is viewed. So these are the examples of the layer names. The first example is A-EF underscore 30 underscore 40 hyphen M hyphen flow. This layer name description says it's architect's floor outline. So these are some of the examples of layer name used in AutoCAD. So this is how this is the format of the layer name, which can be taken from the ribbon panel. You can see a panel called layers. From there, you can select the layer property. And this is how the layers format has to be entered while you giving layers to your drawing. So you can see the format given to the layers. So this is the standard of giving the layer. So that's all about layers. Now let's talk about the next parameter, that is line weight in CAD. British Technical Drawing Standards allows for 3 line type on each drawing. So these are the standard line type given to the given by the British Technical Drawing given to CADs. If you're using a line group of 0.25 mm, that is a default line weight, narrow line 0.13 mm, and the graphic symbols 0.18 mm, white line 0.25 mm, and extra white line 0.50 mm. So these are the standard line weight you can give to your drawing. So you can change your line weight by selecting the match property. Line weight can be changed by many tools, but at first we can talk about the match property. In the ribbon panel, you can see a panel called match property. Here you can change the line weight to line weight, line type, line bilayer, color. But now we are going to talk about the line weight. So you can change the line weight from this panel. When you select the line weight panel, this window will be appear. You can also choose a unit. If you want millimeter, inches, you can choose from here. You can choose a layer from this panel. You can also adjust the display scale And this is how you can select the line weight. So next is you can also set the line weight in plot and page setup. In plot and page setup, now let's talk about the page setup window. So here you can see two options. In the plot scale, you can see scale line weight, and the plot option, you can see plot object line weight. From these two options, you can just select the scale line weight, then only the paper space, the line weight should be shown in the sheet drawing. Only if you select these two options, the line weight will be visible. Otherwise, it will not be visible. So if you want to see the line weight, you have to select these two options. So now let's go to the plot layout. You can also select the line weight on the plot layout. In the print option, you can see two options named print object line weight and scale line weight. Only if you select these two options, the line weight will be visible on your layout. So this is how you can set the line weight on your layout and page setup. So similarly, you can also set the line weight in your layer panel. So when you click on the layer property, this window will be up here. So here you can add as many layers you want. So this is a default layer. Here you can set the line weight. This is the option for line weight. Here you can, when you click this option, these many line weight options will be appear, and you can select the standard line weight. And this line weight is controlled by the layer. So now let's talk about the line weight in plot setup editor. So in line weight, in plot setup editor, you can also change the line weight. So here you can see the line weight option. From here you can select this option, and when you select this much options of line weight will be seen, and you can select the line weight you want. Next is the text and dimension. In text and dimension, the font. The most common font in technical drawing are Arial, Tahoma, Simplex, Roman, etc. And you should never use more than one font in your drawing. And all text should be written in capital case. And the next is the text size. Drawing scale. Text size. So the CAD text size should be proportional. That is a drawing scale to suitable text size at 1:1. And the standard metric text height should be 1:1. And for almost everything, and for nodes, distance, elevation, you have to use text 2.5 mm. And for drawing title, for axis numbering and lettering, for section letter, you have to use a text 5 mm. You can use text 7.5 mm or text 5 mm for drawing title and axis numbering and lettering section letter. And the next is setup text styles in AutoCAD. Almost all CAD software use annotative text styles to easily achieve uniform text appearance. This section presents the configuration for annotative text styles in AutoCAD. So here you can see I choose a text 2.5 mm, and the font should be Arial, and the size annotative should be yes, and the paper text style should be 0.0025, that is 2.5 mm, and the width factor is 1. So these are the settings for text style. Next, coming to the dimension. All dimensions should have the same and consistent appearance all over the printed drawing. The size of the dimension number should be 2.5 mm. The line weight of the dimension line and the size of the dimension arrow should be same. The extension line, that is the connecting the edge of the object to the dimension line, should be same. So this is a dimension style panel. So there are lots of options like line, symbols and arrow, text, fight, parameter unit, alternate unit, tolerance. We can go through all these options step by step. So at first we can go to the line. The dimension lines, the color should be bilayer. The line type should be continuous. The line weight should be 0.15 mm. And the extended beyond tick should be 0. The bezier space should be 0.01. And the extension line, the color should be bilayer. The line type extension line should be -2. And line type extension line 2 should be -2. Line type should be 0.15 mm. And the extended BO dimension line should be 0.002. Offset from origin should be 0.001. The fixed length extension line should be 0.015, that is 1.5 mm. So these are settings of lines. Coming to the next, that is the parameter for tab, symbols and arrows. So the arrowhead, the first arrowhead should be arc tick. The second also same arc tick, and the leader should be closed fill. The arrow size has to be 0.0015 and the center mark should be none. Dimension break size should be 0.004 and the arc length symbol preceding the dimension text. The radius jog dimension, that should be the jog angle should be 45 and the jog height factor should be 1.5. So these has to be changed to architectural tick. Next, we can go to the parameter for text. So the text style, the text should be 2.5 mm. That is a default style, and the text color should be bilayer. The fill color, we don't have to give any fill color, and the text height should be auto by the text style. So that has not to be changed. And then the fraction height scale, that also auto by text style. And then the text placement. Vertical above line, vertical should be above line, not centered. Horizontal should be centered, and the view direction should be left to right, and the offset should be 0.65 mm. So the text aligned should be aligned with dimension lines. This has to be selected, aligned with dimensions line. So let's go to the next parameter, parameter for fit. The fit option, either the text or the arrows, and the text placement over the dimension line without a leader. Scale for dimension features should be annotated. The fine tuning, draw dimension line between extension lines. And the next parameter is primary units. So the next is primary unit. The unit format should be decimal. Precision should be 0. Decimal separator is period. And a round off should be 0.001. The measurement scale factor should be 1. And the unit format decimal degree and the precision is 0. And the zeros suppression need not be selected. You can leave it. And the next parameter is alternate unit. The alternate unit should be none set. There is no setting in alternate unit. And coming to the tolerance. So tolerate method should be none and the vertical position. Here you can see vertical position. You have to select middle. Vertical position should be in middle. So that's all about the dimension parameters. So now let's talk about the scale. The scale command. The scale command, you can see it from the ribbon panel. In the modify panel, you can see scale. The scale command. Using the scale command can change the size of an object in the AutoCAD. You have to use scale using a reference. Use a reference option of the scale command to change the size of the object. So now talk more about scaling. You can also scale your object in block. This is the option for scaling the block object. And you can also scale your object in the insert tab. I enter is a command for opening insert tab. Here you can change the scale. Now is the scale xref and image. Xref for external reference are the entities like DWG files, PDF, or image that can be inserted in the drawing as a reference. So here is the option for changing the scale, choosing the scale. So this is the option for choosing the scale in Xref. Next, coming to the file naming standard, there are some standards for names, file names. NCS recommend the following codes for model files. The first digit is a code indicate drawing type, and the remaining two are an numeration. So if it is gives as FP, then is floor plan. SP, then is site plan. DP is demolition of plan. QP is equipment plan. XP is existing plan. If it is EL, then is elevation. SC is section. DT is detail. SH is schedule. 3D is isometrics or 3D. DG is diagrams. So some more. CP is reflected ceiling plan. RP is furniture plan. P is enlarged plan. CM is composite model. 01 walls, 01 cell and core, 01 floor, 01 floor plate, not plate. Stair for spanning stairs. 0 stair for alternative for stair. Roof and 01 slab. So these are the NCS recommended codes for model files. Next is the number. 1 is for plans, that is horizontal view. 2 is for elevation, that is vertical view. 3 is for section, sectional view. 4 is for large scale views like plans, sections, elevation that are not detailed. 5 is details. 6 is schedule and diagram. 7 is user defined. 8 is user defined. 9 is 3D representation, that is isometrics, one point perspectives, photographs, etc. So these are some of the example. They use NCS recommended codes for model files. The examples are if it is A101, that is architectural first floor plan, A102 for architectural second floor plan, and A103 for architectural first floor reflected ceiling plan, and A201 for architectural building elevation, A301 for architectural building section. Okay. So now the next topic is CAD drafting standards. These are the CAD drafting standard that's units, accuracy, dimension, model space, and model space with paper space and coordinate system, USC. So coming to the units, drawing shall be created using decimal unit. This is already accounted for the standard template and dimension styles are used. The standard dimension style for decimal drawing includes a measurement scale factor of 12 to correct the difference in unit. To insert a block that was created in architectural unit into a decimal drawing, use an insertion scale of 1 by 12. to insert a block that was created in decimal unit into an architectural drawing. Use an insertion scale of tall. Next is accuracy. All CAD drawings shall be drawn to be dimensionally accurate. The same measurement can be obtained by reading a dimension or scaling the printed drawing. Use keyboard coordinate entry as well as command like offset or object snap will help you to ensure that the drawing are dimensionally accurate and precise. Even though the drawing is supposed to be accurate, it is still important to note the contractor that written dimension prevail and that they should not be scaled the drawing. So next is the dimension scale value or overall scale for dimension feature should be set to the scale of a drawing. So the drawing was created in decimal 1 unit is equal to 1 foot unit. And the desired drawing scale should be these. And the dimension scale value should be this. So the correct dimension value is already set in the standard drawing template when you're drawing. So this is the dimension. The dimension should be drawn with an appropriate standard dimension style set current. The dimension style should already be present if a standard drawing template is used. The standard dimension styles are row, the standard dimension style right of a way, EOP standard dimension style for edge of a pavement, plates a standard dimension for plates, and model space based paper space. All CAD line work shall be drawn in a model space of scale 1:1. The dimension and the label shall also be in the model space with the text size approximately to plot the correct text style. The model space drawing can be reduced or enlarged to the appropriate scale by doing the following. So you can reduce or enlarge the appropriate scale to the model space drawing by doing the following procedure. Double click in the viewport to make it active. Type zoom and enter, and then the appropriate scale factor. Double click on the model at the bottom of the screen to return to the paper space. These are the steps you have to follow in order to um, enlarge or reduce the appropriate scale in your model space drawing. So the next is this zoom scale factor. If the drawing was created in decimal 1 unit equal to 1 foot unit, the desired drawing scales are all these and the scale factors are these, not these. And next is the coordinate system. Before that, if the drawing view need to be rotated, you have to double click inside the viewport and enter the command D view, then TW for twist. Then specify the angle to rotate the drawing. This will rotate the drawing view without changing the underlying coordinate system. In order to rotate the drawing view without changing the underlying coordinate system, you have to follow this command. If the drawing need to be rotated, double click inside the viewport and enter the command DW, then TW for twist, then specify the angle to rotate the drawing. Coordinate system USC. The UCS command allows user to alter the coordinate system of drawing. The original coordinate system of a drawing is known as the world coordinate system. Where practicable, the coordinate system of a drawing should be remain set to the world coordinates. So in the coordinate system, keeping the coordinate system set to world will ensure that the xref inserted at the 00 coordinate appear in the correct place. If it becomes necessary to alter or rotate the coordinate system of the drawing, to save the new coordinate system and give it a new name. Also set the coordinate system back to world before insert the xref. So that's all about CAD standards.